Okay, let's go ahead and get started. The clock's actually a little bit behind, but um, this is Math 121, right? Introductory Algebra. Is anyone here today who wasn't here? Was it Wednesday? Oh, yeah, we talked already, so we're good. And this your first day here? Okay, would you like a syllabus? Okay. Okay, very good. Um, and again, the syllabus is available online as well. So, but this is just a printed version. So, and actually, I didn't take roll last time like I should have probably, but this is how we're going to take attendance. And so, if you, as long as you watched the video, you were in attendance. So, I'm going to walk through a few of those. I think I did send an announcement out on it, but we'll just do it for those that are here. So, because not everybody has logged in attendance yet, and not everybody has registered for Math AS. And the ones I'm most concerned about are the people who have not done Math AS and not registered that they were here, um, because I'm giving a limited time. If I withdraw them now, they get a refund of the tuition. If I don't, they don't, and maybe they're not intending. So um, either way, if you're intending to stay in the class, whether you're watching it on video or whether you're here, uh, make sure you log the attendance for the first day. And again, even if you weren't here, you watched the video, you were here, right? So the way you do that is, this is our Canvas course. You'll come in, yours will look slightly differently because I'm not in student mode right now, but you'll go to modules. Let's see, oops, gotta switch over, that's why I got this thing as my monitor. So now the people on the video can see this. And under course introduction, there is this first day class recording, so you can watch that. Does anyone remember what our word of the day was? Paintbrush. Okay, so each class is different. We'll come up with a new one today. So just, someday when you've got a really nice word of the day, you can be the first to share it with us. So you'll watch this, you'll get the attendance, you'll get the word of the day. And this is the way you'll log attendance. And if you haven't done it yet, make sure you do it. Whether you were here physically or you watch the video, click on the attendance quiz. Actually, I think I have to be in student mode for it to show up. Okay, so we'll do it so you can kind of see exactly. Come on. And we have today and tomorrow, or not tomorrow, but you know what I mean, today and Wednesday, to take a look at lesson 1. So we're going to actually start into the course today, but I just want to make sure everyone's on track. So attendance quiz, first day, click here. I guess I didn't finish it the first time. You can take the quiz, and again, what you'll do is you'll click on paintbrush for the first day. Click submit quiz, and there'll be 1 point appears in your grade book, which shows me that you attended class. And again, hopefully you did look through the video, because also there's, what else did we do the first day? Did we do any, was there any points that you could have earned the first day? Didn't I say if you gave me a review of what we went over, there was some points? No, I didn't do that. I should have. Well, let's do that. Because on the syllabus, let's see, it says that there's an introductory activity that's worth 40 points. Another thing I forgot to tell you about the introductory period activity where you can earn 40 points. And just to be fair, in my other classes, I also said, well, let's double it. Let's give you some extra credit to start off with. So we'll make it worth 80 points. I'll post the assignment up in Canvas, but it's just, you're going to write about a half-page review summary of what you learned the first day, of what impressed you, what bored you, I don't know, but your impressions, your experience of the first day. Okay. If you don't remember what happened the first day, you can go back watch the video again or something. But if you have a few notes of what happened, what did we do? Did we do some multiplication with the hands? Okay, good. We got, because each class was a little bit different. I skipped over some things and did some things. We did a little 2-digit multiplication trick. Okay, those are the kind of things. Just write about it, and I'll put a few prompts like, what did you know before? What was new for you? And what are your impressions? So that'll get you the 40 points that you need to get started. Plus, if you get it to me within 10 days, and we'll do it since I didn't do it till now, 10 days up today, you'll get an extra 40 points. Okay, so that's just kind of encourage you to get it done. And where it will appear is it'll be right under the attendance quiz. I'll put a little introductory assignment. You'll click on that and it'll give you those prompts. You'll click on it and you'll be able to either upload a file or type it in. Okay, so, and that's pretty much mostly what's in Canvas at this point. And the syllabus is here. So what I always like to do is I get messages from some people that say, there's no due dates in Math AS or Canvas. And I know some of you may get used to sort of prompts that something is due at a particular time. And I apologize to you if that's how you learn to drive yourself, because I don't do that. So there are no due dates. And the reason I don't do that, again, is because I have to, especially Math AS, if I set a due date, I have to set a time, a minute, a date. And if you do it 2 minutes later, it's late. And I haven't figured all that out. So I said, better let's just publish a suggested schedule. So here we are, our syllabus has a suggested schedule. We're going to start lesson 1 today, finish lesson 2 on Wednesday, and then next Monday we'll be into lesson 2. So you say, well, when is it due? Well, it would be appropriate probably to have lesson 1 completed by next Wednesday or next Monday, but not necessarily required. Sometimes you could have some overlap. So this is where you get some choice, and you know your schedule, and you'll know what will work best for you. Okay, so there's no set due dates. It's just really where you have to have it done. I mean, you need to be ready for this test, right? So all of this stuff at some point should be done. Now, I've got people who will take tests, and then, some of you, I was sort of that way too. Take the test, see how well I did, and then I do the homework afterwards. But really, the homework is supposed to help you get ready for the test. But I was not a stellar student. I look back on it. There's a lot of things I would have done differently, and I would have learned better. I did take a few math classes 2 times. If I would have done it right the first time, I would have been okay. But we live and learn. That's what college is about. So we're going to do lesson 1 today, and then we'll get into lesson 2 next week. We got a week for lesson 3, and then we're going to review, practice test, and then we'll take a test. Okay. Any other questions about the course and how it works? Okay, good. So we'll just put this down. And what I'm going to do is I'm going to open up Math AS. And if you haven't registered yet, you should have gotten an email from me this weekend with a little video that just highlights how to get registered, because I really want you registered. I don't like to do things with penalties, but the sooner you get registered, usually the better for your success. So where do we go? Anyone know the URL for Math AS yet? Okay, that took me a long time. Yeah, we just start typing and it remembers, right? So pvc.maricopa.edu. Yeah, why would you memorize it? But I memorize things by doing them over and over again. And the nice thing about computers and the hard thing about computers is they start remembering for us, so we don't have to remember anymore. We just start typing a little bit and it remembers. But we go on somebody else's computer and then it doesn't remember. But anyway, we're okay. So hopefully you've gotten down how to log in. And And it looks like 3 more people since this morning have registered because I get messages every time someone registers. So good job, guys. Keep up the registrations and then you'll be able to interact. And again, this message, this welcome will go away. I think I've turned it off as of Wednesday or something, but I wanted everyone who registered to get a little welcome to the course. And that's one of the main reasons I'm trying to push you to get registered. So we're going to start right into again, the syllabus is here as well. Course materials are here, some other stuff on tutoring, but the main way to work way through the course is through the lessons. There's 10 lessons, uh, and each lesson is fairly similar of what it contains. There is a mini lesson workbook at the top, and again, you could have this purchased from the bookstore. It's already pre-printed for you, or you can print out the pages you might want. There are many lesson videos, and let's see how many are here. There's 12 different ones here, and this walks you through the mini lessons. So this is one way of learning the lessons. It's exactly the same thing we use for our students who are completely online. So instead of coming to class, this is how they learn. They just watch it. If it worked for you, that's great. And then you could sort of, watch my videos too, so that you're in class. But again, attendance is more about learning than anything else. So here are the videos. Some people say that they don't like these videos, whatever your learning style, and maybe that's why you come to class. That's why you didn't sign up. Some people say I didn't sign up for an online thing. I don't want online stuff. I want to learn from a person. Okay, so we'll get both of these, but that's here. And again, the goal is that if you watch those, you're at least up to date, and then you maybe know some questions. And then when we get into class, we can start talking about some of the topics. These are practice problems. And the way I teach is I'll sort of go over the content, what's involved in the content, and then I work a lot by doing sample problems. And then we'll do more sample problems. So that's sort of how I learned math, and especially this particular class is very much into learning particular skills of how to do things and then understanding concepts by learning how. Okay, so we'll come back to this as far as uh, some of these problems. There's multiple things. Some of you, well, we'll work with it. This is one way. There's answers to these somewhere in here. Then the other thing you have is really the homework is here, online homework. So there's not a separate, I'm not going to say in class do certain problems. You'll just be required to come in here, and these are all the problems you should be able to do. So there's 41 problems, but that's a whole week's worth of work. And again, did I have a certain percentage that I say you should complete? Yeah, about 70% gets you sort of to the first level, but 85% gets you all the points. So 85% is 100%, if that makes sense. So I don't, I put in a few extra for those of you who want to keep trying some things, but as long as you get 85%, which is only 96 points, but so I hadn't done the math on it yet, but get about 82 of them right, and you'll have all the points you need. So you'll get the full points. Okay. And what we'll do is probably today we'll introduce the content. We'll get a little bit into the practice problems, and probably on Wednesday we'll get a lot of time to look at some of these online problems. Even we can work them here in class. There are sometimes some resources online for them, but again, you probably took this class because you want some interaction and you want some direct instruction, and that's what we'll do is we'll work through any together. So after today, it would be good if you could at least start into the homework. And here's my suggestion is that maybe you work like every other problem, especially if you get one problem and the next one's just like it and you understood it, go to another problem and kind of try to get through and see where you have difficulties and where you're understanding. And then we can always come back and fill in the rest later on. So again, work all the evens, work all the odds, whichever your preference is, and then come back and work the other ones. And that way you'll get through the lesson faster in half the time. You'll see the whole lesson, and then when you go back, you're reinforcing things. Okay, does that kind of make sense? Okay. So that's our introduction. And then there's this online quiz. Do you have to do the online quiz? Well, there's no points for it. I think, let's see. I do different things in different classes. Um, but all I'm giving you points for is for the homework. So the quizzes have no value if you want. Or they have a lot of value because they're yours to use. And what I do with some people, or some classes, and this class as well, if you go to the online quiz, because maybe you get a topic that you feel like you understand pretty good, and maybe you've taken this class before or something, you could go directly to the online quiz, and if you get a good score, 85% or better, uh, we could replace, then you don't have to do the homework. Okay. Uh, so you can use it either as a pre-test for yourself to see how much you already understand, or you could use it as a post-test just to see, let me see how well I do on it. Because there's similar problems that are in the homework. So that quiz is yours to use either to sort of test out of a unit or to just kind of solidify at the end to say, yeah, I really understand it. Okay. So it could be counted as points if you want. Again, if you do use it as a pre-test, um, or if you do a bit of the homework, maybe you'd only do half and then jump to the quiz. As long as you're doing real well in the quiz, I can say that's another way to assess you've done what you needed to do. Because learning is not about what you do, it's about what you understand. Does that make sense? I think it does most of the time. Okay, so let's go practice problems lesson 1. I'm going to pull that up so that it's here for us. We're going to, though, actually, let me shrink it down for now. Okay. So what do we need? Let's see. Let me get myself comfortable. So actually, move the camera. So I got from here all the way. There's a little bit of delay. Okay, so I'm getting most of the thing. So what do we need first to get started?
Word of the day.
Good, good call. Who has a nice, positive, inspiring word for our word of the day?
Cancel. Cantaloupe.
Cantaloupe. That is my favorite. Cantaloupe. I don't know if I can spell it though. Cantaloupe. Is that about right? E. Here, isn't it? Okay. Cantaloupe. Okay. There's a song by Cantaloupes that was one of my favorite jazz fusion rap songs. I don't know if anyone know that Cantaloupes by S3. You gotta hear it. Used to drive around to it. It was just a great song. Um, Also, my grandfather in the mornings would cut cantaloupe for us as kids, but he taught us, he had this song, the Cantaloupe Song. So it's a very good song, good positive word. Okay, so what we're going to be talking about in lesson 1 is something called a function. Some of the things we're going to talk about functions could be sort of abstract, but it's a math class, we'll be dealing a lot with numbers, but you could also, the concept of function could apply to things that are not numbers as well. So what are the parts of a function? You should probably know a little bit of this, right? Because from math, if you had math 90 recently, or 91 or 92. So we're going to put the function here. What does a function do? What does a function need? There we go. So the way a function works, it's sort of a black box. It's going to do something, and sometimes we don't care what it's actually doing, but there is something that goes into the box Call that the input. Something happens to it. Sometimes nothing happens to it, but that, nothing function. And then something comes out, output. So, the shower function, I go in dirty and I come out clean. Um, in math, what I wanted to focus on is how many different things do we actually do with math? How many operations do we actually have in math? Is that
Infinite.
infinite? What do you mean by that?
Like an infinite amount of operations.
Okay, so we thinking about answers, so we could get an infinite number of answers. But how many? If we talk about the operation that taking two numbers and doing something with them, how many? We do have a lot, but in when we need to calculate something, how many do we really have? What are the things that we can do to numbers? There we go. Addition, subtraction, multiplication, division. So far four. What else can we do to numbers? That's legal. We don't want to do illegal stuff with numbers. There's one more thing that we do fairly regularly. Raise them to a power, exponents. And we'll be doing those a little bit later. So 5 things. What I want you to think of, though, is I want you to think there's really only 2 things we do to numbers. Really only 2. Math breaks down to just these 2. We can add them or we can multiply. Well, what happened to subtraction and division? But I want you to think that subtraction and division are really just the opposite of multiplication and addition. So they're not really something different. They're just in a different direction. And let me show you something. If we take 5 minus 3, couldn't we think, now that's the operation, right? Let's see, I'm still in the viewable window. That's the operation of subtraction. But could I do this same problem with addition? Yes, what would it look like with addition? 5 plus negative. It's really the same thing. So I can think all I really need is addition. If I got addition button, I can do subtraction as well because I can add a negative number. Okay. So I just want to, because I want to help you look at math as cleanly as possible. It's just really addition. Everything is addition, especially with algebra, because what can we do with addition that we can't do with subtraction? If this is a plus, we could also write as negative 3 plus 5, can't we? We'll get the same answer. But could we switch the order here and write this as 3 minus 5? No, because this is negative 2 and this is positive 2. So you see, subtraction has a few extra rules, and it's like it's not as flexible. Addition is very flexible. So as we think of functions, if we start to think in the way we calculate, everything is addition. With algebra, that's just a bonus because it makes doing it so much easier. We can switch it around. Okay. And if you haven't, that's kind of the new way they're going through and teaching math 082, or 081. At the very beginning, they try to get you to think of subtraction as adding the opposite. But if you haven't had that, I'll introduce it here. And especially when we're doing algebra, we'll see if that makes a difference for us. Let's think about another thing is the other operation we talked about, 3 times 4 equals 12, right? When we want to talk about division, so what if I had 3 divided by 1/4? And this is where we'll kind of see it. When I take 3 divided by 1/4, how do I actually go about doing division with fractions? Okay. Oh, well, I could do that. Then I multiply. What I do is I flip the second and multiply, right? I do the reciprocal. So I don't actually divide when I have a fraction. I think of this as 3 times 4 over 1. So just flipping the second one, right? Now I multiply, I still have 12. So what I want you to think about is division can always be characterized as multiplication of the reciprocal. Okay. So even this one, I guess, yeah, if I was taking 3 divided by, actually, let's do the numbers. If I was thinking of 12 divided by 3, how could I do this with multiplication? Very good. 12 times flip a third, or flip 3 is going to become 1 over 3. Now, when you take 12 times 1/3, what do we get? If you do it with the way we do fractions, you multiply straight across, you get 12 over 3. Well, isn't that just 12 divided by 3? But if you did the multiplication, you'd see it is definitely 4. We won't push it too hard, but division, we could get away without division. We just multiply by the reciprocal. So we only really need two buttons on our calculator. Multiply and divide. Oh, no, sorry. Multiply and add. Okay, so these are the two that we really need, and we'll get by. Now, sometimes it's just convenient to say 12 divided by 3. Okay, I'll give you that much. But wouldn't it have been so much easier to have gone through elementary school, middle school, all this math if we only had to learn to add and multiply? And then when we get to exponents, we're going to see exponents is just repeated multiplication. So it's not really, I mean, we'll have it's nice to have that special button instead of having to take 3 times 3 times 3, 5 or 6 times or whatever it is. But we could get it done with just addition and multiplication. So if you learn nothing else today, you learn that there's only 2 operations in all of math that are really of any value. Yes.
So you said subtraction was the multiplication at the reciprocal. That was your definition for subtraction? Or
Division. Division, my definition of division is that it's really multiplying by the reciprocal. My definition of subtraction is it's adding the opposite. Okay. And again, you've probably had 12 or 16 years of other people telling you that there is subtraction and division and such, so I don't expect you to pick it up right away. But you're going to see as we do this, it'll hopefully make our thinking algebraically more flexible. Because again, multiplication, we can switch the order, but division, we can't. Division has to be done in a certain order. So we pick up some benefits. Okay. So inside this function box, if we think of all that's going to happen is we're going to take a number, we're either going to add something to it or multiply something by it. And sometimes we'll get complicated functions where we're doing more than one thing. We might multiply it and then add something, or, so there might be multiple steps in here, but we're taking a number, doing some math with it. And again, there's only 2 things. We're either going to add or multiply. Stick a negative on it, take a reciprocal. Again, that all will happen. And then we get a new number out here, possibly. Some functions we'll see, there's a function that doesn't do anything, but it's still called a function. Multiplying by 1 is a great function. I love that function, multiplying by 1. You put it in and you get it out. It's real nice and smooth. But this first one, we're talking more about the process of a function, the language of functions, and the symbols that we write to represent functions and what they mean. Okay. So input, output, in the middle is the function. Okay, so we've got this. We can deal it with just 2 operations. What are some other things we would associate with input and output? Some other words, some other letters, some other things. Yes. Yes. And then we've got a function that relates time to distance. So you're already thinking of, yeah, if we put time in and what do you do to time? I think you divide it by the rate and you get distance, so there's a relationship. Good. But how about more generalized? What are when you think about input, what do you think about? Okay, investment return. I put some money in, they give me some interest, and I get a return out. Hopefully. Sometimes we lose money on an investment. These are good things. How about letters? There's 2 letters. There we go, algebra. Where does the X go and where does the Y go? Good. When we see X, we're thinking input. Very good. If I wrote the books, I would have X, the input would always be X. Sometimes it's going to be T for time. Sometimes they're going to change it, but sometimes it's just easier to this. And then you're right. Output must be the Y. Okay, so when you see X and Y, X is our input, Y is the output. Very good. And then the function is what sort of happens to it in the middle. We do something to X and we get a new number Y. Um, what other words have you picked up in your mathematical learning career? Slope. Good. We're going to get to slope about lesson 3. Let's see. Um, slope is a funny one. It's sort of, slope becomes part of the function usually, but it's a relationship between the input and the output oftentimes. So but yes, slope is sort of kind of in here. It's part of functions. Good. How about if I mention the words domain and range? Have you heard those words before? No? Okay. Yes? Which one? And again, they're just separate. So what I want you to understand is function separates the mathematical world into either inputs or outputs, or something in between. And like slope is that one in between. So I guess there's 3 divisions. We're either in the part of the function or the input or the output. So domain, where does domain go on our diagram here? It is. It's a representation. Now the domain itself is not just a single x, but it would be all the possible x's, all the possible things we could put into the function. And sometimes there's things we can't put into the function because the calculation won't go through. Okay. So domain and range, where does range go? Range is our output. Very good. So far, so good. Is it coming back? Okay. So with some notation now, we write x, we write y. There's something called function notation. And what does function notation look like? Good. We get a parentheses. So we write something. This is the standard one we're maybe used to. F of x, right? This is red. F of x. Okay. It's not f times x, it's f of x. So let's break it down into what f of x actually is. What is f of x?
X is the function, isn't it? So it's part of whatever the equation is?
Yes. So f of x itself.
X is a part of f, therefore it's a variable.
Okay. There we go. So what is x? The input. So really we could replace this. We could also call this. So, but the key part is to remember whatever's in the parentheses is the input. Input in parentheses. Okay. What is the whole symbol itself meaning, though? Yeah, we do use it in that form. We use it to define what the function does. So we oftentimes write it f of x, and then we tell it take 2 times x and then add 3. So we define the function with it. And so this case, we put a number in for x. It goes in here. We do something to it. And then what do we end up with? With an output. Good. So this is the hard part of it is it's a complicated symbol that contains the input, but itself, the whole symbol is actually the output. So another way to look at input is the input is the x part and the output is the f of x part. And then we could call the function itself f. So f is the letter that we use becomes the name of the function. Okay, so it's complicated, but yet it's also very elegant when we learn to use it properly. But I remember using it for a long time, and it was really, it was hard because I got used to working problems like this. And so now I've got, that symbol's actually got two pieces to it, right? It sort of represents the output, but it's got the input in there too. Okay. And in this lesson, we're going to get some practice with using this function notation. Uh, and sometimes we'll come back and we'll just replace the f of x with a y because we could, because that's actually what it is, right? F of x and y are really both the output. We could use either symbol. But just remember when we're using f of x, it is complicated. It's got more, it's got stuff in it. It's got the name of the function, it's got the input, and it all together represents the output. So it's almost like something that transcends all three of these at the same time. And then sometimes when we refer to the function, yes, we refer to what it does, as this as a function. And sometimes when we're talking about function, we're just looking at the inputs and the outputs, maybe in a table of values. Okay. Let me get rid of some of this. Okay, so addition, multiplication, that's all there is. I'm going to give you two more words and let's see if we can figure out where they go. Independent and dependent.
Independent under X.
Good. Good. So a lot of this stuff, so this is the independent variable as well, and the dependent variables over here. Because X you can choose any number, but Y depends upon what you chose. It's a way to kind of think of it. But to me, I go with letters, input, independent. Those match up. Domain, D comes before R, X comes before Y. So however you figure out the ways to organize this in your ways of thinking, because that is one of the hardest part of math is you get one thing mixed up with the other. Okay. Yeah. And it's you really are there, but you just mixed up the input and output, and then now you got something backwards. Okay. But that's okay. You're also like one step away because you just switch it over and you're there. But that's one of the things I felt with graphs. So that's a function in general. And I'm going to talk about the three different ways we have of characterizing a function. Okay. Actually, we've already talked about one way sort of just by what we did. So there's one way right here. And we call this the symbolic rule, or an equation if you want. Okay, so, and this is really what you're used to doing with algebra. But in the homework and such, sometimes they'll say, what's the symbolic rule? Well, that just means what's the equation, what's being done. And again, notice there's two things being done. You take x, you multiply it, and then you add it. So part of this all also adds into the order of operations. Okay, so we'll work through some of that. We will use our graphing calculators at some point in this section, and the calculator will handle a lot of it for us, but we'll just see. Okay, so we have a symbolic rule. What's another way we can represent a function? What if I give this part? What goes at the top?
Input.
There you go. Input, output, X or Y. Could be either one. So we could call this one input and this output. Or we could say this is X and that's Y. And our calculators will generate these as well. And it could be some sort of random thing. I don't know if there's a pattern to this or not, but this is part of what we're going to do. We're going to see tables of values where the one side's the input, the other's the output. Okay. When we write it this way, we will follow a convention where the left-hand side is the input, the right-hand side is the output. Now, you could do it the other way, but this is this is why we have these conventions, because we get used to seeing it one way. And if we're switching it all the times, then it's hard. If we do it another way, which is top and bottom, what goes on top? Input. Usually we would put, now again, it's not a hard, fast rule. There's no reason why we couldn't put the input on the bottom, but we'll follow along. If people are doing it in a kind way, input will go here, output will go here, and I'll just use the same numbers, 1, 2, 3, 5, maybe like this, and 4, 7, 8, and 9. Okay, so same meaning, just a different orientation. So we've got a symbolic rule. We've got this, which is called either a table of values or numeric representation. Numerical, we'll go. Okay, so that's another representation where we just give you the input, give you the output, and that's all we tell you. That's still a function. Okay. Symbolic rule, numerical, table of values, and what would be the last one? That one more way to represent a function. Who said it? Graphing, right? Graph, yeah, a graph, which will use an X and a Y. So we do a sort of this cross thing. Which one's X, which one's Y? Good. I like to do it this way too. This way, because it's also called horizontal, but I get those mixed up. But yeah, so usually we have the X going horizontally, and the vertical is going to be our Y. So this is our input here. This is our output up here. And again, that's why it takes some, once you start doing it a lot, you get used to it. And that's why sometimes when they switch letters on us, it becomes difficult. Okay. But this is how we want to see it. And again, some of us might have a more natural, we have our spatial ways of reasoning that we develop, but I figured out partway along it, I did it differently. I sort of was thinking of the vertical as input and this is output. So that's where my struggle was, is I had to get my internal way of thinking reversed to fit the world around me. Why can't they just turn it like I do it? Well, they have to do it one way, so they did it this way. My natural way of thinking was switched on it, but and sometimes I still go back and forth, especially when I get tired. It's harder to do, but we have some activities as you go through. Notice what I want you to do is I want you to spot where your difficulties are coming, and don't just say, "Oh, I don't understand it because I'm getting it wrong." Start to try to be aware when you transpose things, because you might have a very powerful way of seeing mathematics. It just might be the reverse of how the conventions have been set up. You might be, especially, I think I was supposed to be left-handed because I tried to do everything when I was a kid with the left hand, but back in those days, in the 60s, they said, no, everyone's got to be right-handed. And actually, I can write backwards with my left hand, which is kind of a cool trick to be able to do. And I was learning about, who's that guy, the scientist from Italy. He wrote backwards. The famous guy. He wrote that. He did artist. The Da Vinci. Yeah, Da Vinci. When I learned about Da Vinci, he used to write his stuff backwards so that you hold it up into a mirror. I think it was about third grade. I learned about that. I started teaching. Yeah, because the Inquisition, if the science he was learning, if it was against what the church says, they were burning people at the stake and hanging them and stuff. So he didn't want people coming in and saying you're doing witchcraft and stuff. So he would just write it backwards so nobody else could see it. When he wanted to read it, he put it in the mirror. Um, really cool. But if you work with me in tutoring, a lot of times I'll sit on the other side of the desk and I can actually read better upside down now. Just these little parlor tricks that I learned. But it was because I learned I did things differently, and I learned to do it as a strength rather than a weakness. So as you go through, if you're struggling, don't think that it's wrong. It's just different. And then that'll help you find ways to adjust and do it the standard way, but it will also leave you with your strength that you have of seeing it in a particular way. Okay, so we draw a graph, and we've got various points on here, and this point we represent, let's see, as some ordered pair. We represent it as an input and an output, which we list as an x and a y, or an x and an f of x. Okay, so we start seeing that there's multiple ways to write things. And that's a hard time. A lot of times when we learn something, we want to learn it one way, but in math, we write things in multiple ways, and we just have to learn it. And that's like if you ever get into calculus, there was two ways of doing calculus. One, the Germans, and I think who's the guy? Isaac Newton, British guy. They both came up with ways of doing calculus, but they wrote them differently. And that was the hardest part, is they taught both ways of writing the calculus the same way. That's why it took me 2 times to get through. I just couldn't get through the way that they wrote the things. I favored one, but not the other. Okay, so this could be a particular input output. Could be an x, could be y, x and an f of x. Okay, so we'll locate those on there. And okay, so those are all the different ways of representing functions. This is sort of what a function is. And now I come back to where most people would start, is there is one rule that really defines what a function is. Yes, it is a relationship between an input and an output, but there's a special rule that not all relationships, not all matching of one number to another is a function. They're all relationships. Yeah, two things are getting hooked up, but a function has a special rule. Does anyone remember or know what that special rule is?
You can only have one.
Yes, you can only have one. That's the easy. What can only have one?
An input can only have one
Output. Exactly. Input can only have one output. And notice that's a one-sided rule. It says nothing about the output. It's kind of like open season. You can do whatever you want if you're an output. You can have as many inputs as you want. If you're an input, you can only have one output. Okay, that's the rule of the function. Let's write it up here. That's still visible. Each input, and I'm going to put, because there's kind of this area of if I have an input and it doesn't have an output, is that a function? And if I think the activities you'll see, there's 2 ways to look at it. The way they look at it is if an input doesn't have an output, it's not a function either. So I'm going to put each input must have only one output. And as long as we follow this rule, as long as the function is a function, as long as it follows this rule. So part of what we do in this section 2 is we look at things that are not function. The cool thing is if it's not a function, what do we get to do with it? Ignore it, not do anything with it, because we only do functions. When I was learning, one of the things we'd start off with is a circle. We'd start doing the algebra of circles. And let me ask you something about a circle. If you think of a circle, this is input, this is output, right? I draw a circle, any circle. Does this circle satisfy this rule? How can we tell? How did you know? Okay, so we choose an input. Whatever input this is, let's call it, looks like it could be 3. How many outputs does that number 3 have? It's got 2. It's got one up here and one down here. So there's a point 3 comma something, and there's a point 3 comma something up here that is different. So we'll call this one y1 and this one y2 just to show that they're different. Okay. An input has 2 different outputs. Violated the rule, we're not going to talk about it. Again, when I was going to school, was it back, I remember I went to University of Washington my first year, fall of 1980. One of the first things they started doing is the algebra of circles. It's pretty complicated. I would have liked for the function stuff to have taken off sooner, but it was about the 1990s where they started to, every functions became the center, and even more recently. So if if you've never talked about functions, it's stuff that, but the last 20 years, that's what they say, all mathematics is getting wrapped up into functions. So circles don't get covered until later when you look at mathematics that are not functions. Okay, so it's, I mean, there's value in circles. Trigonometry has circles, but they look at when you do trigonometry, you define the circle differently so that it's actually a function. And you can, so that's kind of a cool thing. You could take math and take something that's not a function in one type of math, algebra, this is not a function, but in trigonometry, they look at it differently because it's about twisting around and stuff. And they take something from algebra that's not a function, and in trigonometry, it becomes a function. It's kind of cool. So that's the thing with math, is it's about your creativity and the creativity that they found. So far, so good. Okay, I think I've just gone from A to Z in lesson one. I think we've got about everything we need. And the way we find out is we go look at the practice problems. We're going to look at a few of them. We're going to go through them, and we're going to see how well we do. And if all of this sort of characterizes what we need, if we missed out on anything, I'll say, oops, I forgot about that. We'll add it in here somewhere. Okay. So let's, where'd it go? There it is. Okay. Hopefully everything's going good. One of the frustrations I had this weekend as I'm trying to make a few of the videos, a few short videos, sometimes I forget to hit the record button. So I do this great recording and it wasn't recording. So I kind of try to watch it while I'm in class that I'm actually still streaming, and it looks like we are. Okay, good. Okay, so the first example they're going to give us, oh, sorry, people at home can't see this screen. That's what we want to see. So the first example they're going to give us is a table of values. So it's fitting into this way of looking at a function. Okay. We don't know the equation. It may not have an equation. That's another thing with functions. It might not have an equation. A lot of them, part of this class is what we're going to do is, it's, how many of you have heard of regression before? Regression. Okay, what does it mean in general? To go back. Good. And it sort of means that with math as well, we're going to go from the data back to finding an equation. So that's, and your calculator will handle all of this. But we're going to do it with various different types. And that's what's really cool, is because that's what research does, is in research, you manipulate something and you get some data. You get an input, you know, when the temperature is this, or when the time is this, the output's that, something like that. You get data. What we do to mathematize that is we take that data, we do regression on it, and get an equation to fit it. It might not fit perfectly, but that's really what research is about. Because then when you have an equation, what can you do? You can then see different inputs and outputs from that equation, and you now can test something without physically actually testing it. And then you could test it later. So that's what we're going to do. So in here, what is input? The input's time. So identify the input quantity and variable. Now, they say to include units. So the input quantity is time. What would be the units? Minutes. So it's not seconds, it's minutes. So that's another thing. Everything, when we talk about a variable, there has to be units attached. And if you keep those units attached, a lot of times it's easier to figure out, because whenever they're talking about minutes in a story about this problem, what are we talking about? Input, right? If it's talking about minutes, we're in the input. What's the output? Distance in kilometers, right? And we might not be real familiar with kilometers, but if we see a word, if there's a story problem that says something about kilometers, what are they talking about if they're talking about kilometers? Distance, which is the output. Okay, so this is what, because that's what we're going to focus on in this class, is once we get things set up, I either give you the input and ask you for the output, or I give you an output and ask you to give me the input. That's all there is to do. And that's what I wanted you to see, is that there's only two operations, addition and multiplication. There's only two possible numbers, an input and an output. Isn't that cool to have math broken down? It can only be left or right. That's the only two. It's either true or it's false. It's either an input or it's an output. And there's only two things we're going to do. We're going to learn how to start with the input to get the output. That's one process. Or we're going to start with the output and go back to get the input. It's a different process, sort of, because it's backwards, but it's sort of the same process, just reversed. So that's all we're going to do. Isn't that cool that there's just two things we're doing? Not three, not four, not five, just two things. That's all this class is about. Now we get some complications in there. We always do. Okay, so we won't do all of these. So we identify the output quantity and its variable. Write the data as a set of ordered pairs. Now this is where it gets a little tedious, but let's pick a few of them. So this first one, 0, 0, how would I write that as an ordered pair? Okay, so let me see. I think I can do this with, see if this works. So I could write this as, oh, let's see, hold down the Command Alt. Command Alt. It's supposed to let me write. It's not letting me write. Okay. So we'll come back here and let's see. Let me take down some of this stuff here. We'll go back and forth. So we could write it as 0, 0, 20, 4003. Oops, not quite like that, and so forth, right? Okay, so we'll switch back to the table. So we can do that for all of them as ordered pairs. And again, it's just getting order. X comes first, or in this case, T. The Y comes second, which is D. So I always try to think of things in terms of X and Y, because that's pretty clear in my mind. You start using other variables, it gets a little harder. Okay. So write a sentence explaining the meaning of the ordered paired 40, 9452. So 40, 9452. So what does that sentence, what would that mean?
It takes 40 minutes for a satellite to travel 9,452 kilometers.
Okay, so input is minutes. Let's come back here. Input is minutes, so this is, we just have to write it with its units. And then add some words. It takes 40 minutes. And then what were we talking about? We have to read the story. It's talking about a satellite. So we just fill in that. Satellite. Is that spelled right? No. I like to mix up my E's and my I's. There we go. That's better. Satellite to travel. And again, the output again, we linked it up. It's kilometers, it's distance. Um, 94.52 kilometers. So we notice how they give us the units, and so it's going to be real helpful in helping us to come up with sentences. It's also going to be helpful when we read something with a sentence. Um, and we're looking up the input, finding out the output. And that's the nice part about it when we have a table of values. Did we have to do any math? Well, we'll say we didn't do any calculations, but what we did was called math. Looking up a table is math. Okay, very good. Okay, what else do they want us to do? Is distance from Earth of the satellite as represented in this table a function of time? Why or why not? So this is where we're getting a little tricky. These last two questions, I'm going to put this up here. And because the way the question is worded, they're switching the input and output. One is the input, one's the output. And this one was, I remember, being a difficult one for me to understand. And so I'm going to take it down right here. Let me switch back. Okay. So here's the deal. This is the part of the sentence that you'll typically see always in there. Whatever comes first is actually the output. What comes second is it's saying that's the input. Isn't that sort of backwards? How? Because we always think of input first and then output. When we look at a table of values, we see input and then output. But in the English sentence, to describe what a function is, something is a function of something. The first thing they're mentioning, they're telling you that is the output. They're telling you this is the input. It took me years of deep therapy and stuff to come over this. It just didn't make sense to me. It seemed like this should be the input and that should be the output, because they don't put the words input and output, right? Just like on this one. So let's come back and talk about this sentence. So is the distance from Earth of the satellite, so a lot of words, right? But what do we want to focus on? A function of time. So what comes before a function of time? Input or output? Output comes first. So they're saying that this is output. Okay, so it's set up like the table, okay, because the table's set up with a function of time. So they're saying time is the input, distance is the output. So does each time have its own output? Let's go back up in the table. Oops, how did you do that? Okay. And we just kind of check. 20 has its own number, 40 has its own number, 60 has its own. We don't ever see the number repeated. So each number has only one output. Now, is it okay that 100 and 120 share the same? Yes, that is okay, because a function doesn't say anything about the output. It's just that this input, 100, can only have one output. It's just a shared output with 120. So this is a function when we say is distance a function of time. Okay. Anyone else have a struggle with this? Some of you probably just, especially your English majors, maybe it's good for you. But for me, this was like the hardest thing to get down. And I have notes where I write down a function of. Output is a function of input. I write this down all the time because then it'll get me down. So yes, it is. Okay. So we've got that going on because all the inputs each have only one output. Now let's look at the reverse of this is time after launch. Is time a function of distance? What did they just do with us? They switched it around. They're making time the output and distance the input. And when we do that, we come back here. And what we've actually done is now it's like, let's reverse this. This is the input, and these are the outputs. Do we have any problems? We have a problem, Houston, right? Because that's where they launch every. Well, actually, they didn't launch them from Houston, but that's where they controlled everything. In fact, my dad, this is a cool story. We used to live in Cape Canaveral, Cape Kennedy, it was called at the time. My dad worked for Boeing on the Apollo's projects. I think it was Apollo. I got a little thing. I think he was on Apollo 8 or something. He worked on the 12th chamber engine. He was one of the engineers, and we'd go watch the launches. And we left that area, moved to Oregon about the time of the. I think when we left, it was the launch to go to the moon or something, 1969. If someone knows the history. Anyway, so there's a problem here that this 20,200. If you think of it as an input, it's got two separate outputs. So we can't switch it. Okay, so it's not a function if we think of it as the input is distance and the output is time. Okay, and there's things like that. Perfectly good function one way, but if you switch it, it's now no longer a function. Okay, and we'll talk about this a little bit. You'll look at this more in Math 150 when you get there. It's this. If it's a function both ways, if you switch them and it's still a function, then it's called an invertible function. This one's not invertible because you can't switch the input and the output and still have a function. It's okay. How's that for the first day? So far, so good. Okay. We've got till 2:45, right? Let's see what else we got. And then we got another example, but this one is about number of gene copies and time after observation. So this is what I'm meaning is we did one. If we feel like we understand it pretty good, we move on. We don't have to do this one again. And I'll sort of, in the homework when I go through, I'll leave you something to do on your own, because that's the only way to do it. So I would skip over this, but again, you'll see it's sort of the same setup. As long as you know input, output, you can read it from a table of values. As long as you have this written down somewhere, you'll be able to translate what the English is really saying. When you always recognize that the output comes first in an English sentence like this, the input comes second. And for me, it's sometimes a painful switch I have to do. I have to slow down. And that's one of the things I found is when I try to do math too quickly because I want to go watch something on TV or something, that's sometimes when if I just take a few extra minutes, I'm okay. But when I try to go too fast, I start making mistakes because a lot of times math is this way. There's a particular order of things. Okay. Another one. Okay, so you see a few, several examples. Oh boy, 4 examples of the same thing. Let's just kind of keep moving. And each one brings out something. Okay. We're going to take a few quick looks at these multiple representations. So what do we have here? So question number 5, we want to determine whether these are functions or not, whether the ordered pairs are function. Again, what's the only rule we have to meet? Each input has only one output. We don't care we don't really have to check the outputs. We just have to check that each input has only one output. So where are the inputs when we talk about an ordered pair? The X or the first one. So out of 2, 4, 2 is the input. Is this a function? How do we know it's a function? Each input has only one output. Each input's only appearing once. So here's another thing you'll see is for something to not be a function, you have to have the same input appear again. If each input only appears once, it's automatically got to be a function. Okay? But just because it appears twice, it could still be a function if it had the same output. So there's a few tricky ones in here. So how about this one? We're just looking at inputs. 3, 4, 5, 3. Oops. 3 appears twice. What does that mean?
It's a function.
It could possibly not be a function, but now we got to be careful because they have the same output. So they just listed it twice. So that's okay. So watch for that. I do this on one of my tests. I'll put one that's like this, and I change this like I change it from -2 to +2. If I change this one to a +2, isn't that now not a function? Because they're two different outputs. But if I leave it the same, it is a function. Okay. So just because an output appears twice doesn't mean it's automatically not a function. It just means we have to check it. We have to get its IDs out and stuff and make sure it's got its papers in order. It's got the same. It's not playing the field, as it were. It's got its match. So B is a function because when 3 is repeated, it has the same output. We come down here though to C. We've got 3, 1, 2, 3. Now it's this one. How about C? The 3 is repeated, but it's got different partners now. It's hurting somebody's feelings. That's the way we look at it. Okay, so somebody's going to get their feelings hurt. This is not a function. Okay, right? So because, and again, it doesn't matter if we drop off that last point 3 comma 5, then we could call it, then it's all of a sudden a function. But with that 3, 5, one bad apple spoils the whole function. Okay, so just one of it, that's all it takes. How about D? 5 minus 5, 6 minus 5, 7 minus 5. They've all got the same output. Is there any problem there? No, there is no law against the output having multiple inputs. So it's a double standard, yes, but it's still a function. Okay. And we're going to see this is actually a fairly valuable function. It's something called a constant function. That's what happens when we have a horizontal line. Okay, so that we want a function. Okay, and I'll skip over the next one. Next one, last one, E, definitely a function. Different inputs, so it's a function. Okay. Here's another way. It's just a different way of looking. Instead of an ordered pairs, looking at table of values. Maybe I'll come over here and use the mouse. So we're looking at A right now. So input are the X, output are the f of X. Is this a function? Three, 1, 2, 3, 4. 3 is repeated, so we check, does it have the same partners each time? First time it had 0, second time it had 12, boom, it violated the law, it broke the rules, it is not a function. So what do we get to do? Ignore it. Cool. So that's really all this part is about. It's really a true false answer, and if it's false, it's not a function, we don't deal with it. Okay. In B, we start to see that we can use something other than f of x. We could call it g of x, basically giving different names. How about g of x? Is it a function? Yes, each of the inputs is different. 0, 1, 2, 3, 4. There is no way for it to not be a function because each input is different. They've all got to have their own. I guess the only way for it not to be a function is if one of them didn't have an input. I think, yeah, they don't give any of those for us, but because the definition is that if you have it as an input, it's got to have an it has to have an, because that would be, that'd be like you're the kid that didn't get chosen for the team. I was at sometimes, they choose teams and look, we don't need that guy. We need to feel sorry, alone. So we don't want anyone feeling sorry or alone. So we want to have everybody to have a partner. Okay. And again, you can go through these. Let's just take a look. Let's jump down here to G. G. And it's a horizontally listed. Inputs on top. Inputs always -1. There's the outputs. Is this a function? It's like our majorly non-function. In fact, what would this be? X is always -1. This is a vertical line. And you're going to see, it might even be in this lesson. I didn't look real closely. But that's one way of testing for a function is something called a vertical line test. We do that with a circle. If you draw a vertical line and it hits a graph twice, it's not a function, twice or more. So there's a vertical line test because a vertical line is the most non-function there is. The input's always the same, but it's got so many different partners. Yeah, you don't even want to touch it. It's a vertical line. In fact, actually, the mathematics of vertical lines is kind of difficult to work with. But it's a non-function, and it really is the only non-function we'll use in this course because we find a good benefit of talking about vertical lines. Okay, so here we are to the graphical, and this is where we're going to use that vertical line test. and take a look. So let's just take a look at A. If I draw a vertical line everywhere, is there any vertical line that will go through 2 points? No. So is this a function? Yes, each input has only one output. How about B? Vertical line, is it going to ever touch more than 1 point? No. Now it gets really steep here at the ends and at the beginnings, but it's still it's still okay. It won't touch twice. How about C? Is this a function? Vertical line, vertical line, vertical line. Yes, it's okay. It's a function. How about D? Vertical line, vertical line, vertical line. This last part, it does kind of loop back on itself. So this little part here, I could draw a line that's going to go through more than 1 point. It fails the vertical line test. It's not a function. Make sense? How about this E? Not a function. And you almost see it, if you train yourself right away, you see 1 point above the other. This vertical line that would go through here touches 2 points. It's not a function. Everything else is perfectly fine about it except those 2 points. Okay, so not a function. And how about our circle? We kind of talked about this, but certainly now with the vertical line test, a vertical line drawn through here will touch in 2 places, not a function. Very good. So we're not going to talk about circles, which is good because that was the most confusing part. If they had never talked about circles my freshman year of math, I would have gone so much better. But math of circles is hard when you're talking about the algebra circles. You get the trigonometry, it's okay. But doing the algebra circles, that is very because it's got 2 squares in there and you're having to do square roots and all sorts of stuff. So it's nice that we don't have to deal with it. Okay. I'm going to let you kind of go through these. Maybe we'll do 1 or 2. Let's we got A through E. Somebody choose a letter. A. Okay, good. We'll start with A. So is a person's height a function of their age? So a function of an age, what comes before the word a function of? The input or the output? So they're saying a person's height is the output, their age is the input. So what are we checking to see if this is a function or not? At a particular age, can you have more than one height? Yeah. So if at a particular age you could have 2 different heights, then it would not be a function. But at a given age, can you be 2 different heights? Now you might think, well, yeah, I grew a lot during my year, so if 3 years old from 3 to 4, but I guess, yeah, when do you measure? Do you measure at the beginning of the year or the end of the year? If you measure multiple times during the year, then this is not going to be a function if you're a growing child, or if you're like an aging man like me. I think I'm getting shorter now. So my height is changing, but in a different direction. Uh, Maybe I just need to stand up straight. But that happens over a year's time. We could say maybe our height's going to change. But if we measure at a particular time, the beginning of the year, the end of the year, we would say it's okay. At a particular age, I'm going to be 1 height. So that would be a function. I would say so. We could also argue that it's not, depending upon how you're interpreting this. That's why these are hard when we get away from just talking about numbers and equations and stuff. So I'm not gonna test you on any of this, but it's good practice because when you come into problems, is the growth of the C is the growth of a tree a function of the monthly rainfall? What's the input? What's the output? Monthly rainfall is input. The growth of the tree is the output. So could I have a month where I had the same amount of rain and different growth? Sure. Or yeah, you could have exactly the same amount of rain, but different levels of growth, maybe based upon temperature too. So it's possible. So this might not be a function. Again, I'd have to see the data. It could be a function, but it's not something that's going to guarantee a function. Okay. So, and then we got some longer ones that are just too long to read. So we'll let you give a try. But again, remember, just take those words, a function of, Whatever comes before is output, whatever comes after it is input. Okay. And then just try to figure out if that relationship guarantees you a function. And not just kind of explain it. There's, it's like I said, there's really no right or wrong. It depends on how you explain what you're doing. Like the growing, you say, well, I could, if you've had a kid, you probably do measure them all throughout the year. You don't just measure them at the beginning of the year or the end of the year. You're measuring them sometimes every week because kids are saying, I think I grew. Let me go measure. So that would happen. Okay, good. And let's kind of end here, and then we'll come back to function evaluation, which is kind of a whole new topic on Wednesday. So this final part is we're going to look at there's three ways to describe a function in general, and it's based upon its movement. Uh, so going left to right, and that's the other part is again, some of us can actually, when you learn to read backwards, that's kind of cool. But when you read a graph, you've got to learn to read it from left to right. I also took Arabic for a year when I was at college, and the reason I took Arabic is I liked it because it reads the other direction. Um, and I think, part of it is where does algebra come from? What ethnic group is responsible for the word algebra? If you think of the word, it comes from Arabic. It means literally to take apart, algebra. Um, and so the Arabs, remember, are people that their language was written going from the right to the left. And sometimes things that they wrote were just copied over the way they did their equations, but they would have been thinking of it from right to left. We're now reading it from left to right. So there is a lot to this when we deal with algebra of seeing things backwards of how they were supposed to be done. Okay, so even that sentence in Arabic, if we translated it, they would have seen the input first because of the way they write it. So when we read from left to right, a graph is increasing. Now notice on a graph, if we go left to right, X, the input is always increasing. Left to right, input is always increasing. So what we're reporting is what happens to the output as the input increases. Okay. So this first one, A, what's happening to the output, which is represented by this horizontal line, as the input increases? Does it go up? Or it's constant. So that's one thing that could happen is no change or a constant. Okay, horizontal line. Good. Uh, B, as we read from left to right, we kind of follow, if we were this little ant walking along this line, what is happening to us? Decrease. And again, the output is decreasing as the input increases. Input will always be increasing because we're reading from left to right. And this is where I get in trouble because sometimes if you read it backwards, you could see it as going uphill, right? But we want in math, in this algebra class, we always want to read from left to right. So we see this as a decreasing, a downhill line, always. Okay. And again, it's a powerful thing to be able to think left and right and right and left, but it also can get us in trouble in certain aspects. Finally, C. Well, not finally, but we got a couple. C is increasing. Okay, as X. How about D? It's increasing. E, decreasing, always going down, slightly different rates. And F, finally, the constant. Okay, and we will deal with some functions that increase for part of it and then decrease and decrease and then increase. So, but these representations is what we'll be talking about. And actually that gets you right into calculus because that's what the calculus is about, is what happens at a particular point. Is that next point an increase or is it a decrease? It's about talking about the rates and the rate of change and direction of change. So this is getting you prepared for that calculus class that you may or may not need to take. Again, many of you will, if you're in the business, you'll be taking a business calculus. If you're going into the sciences, you'll take a science-based calculus, but it deals with these basic things of slope, which is rate of change, and direction of the change, whether it's going up or going down. Okay, and then what we'll do, got us through 1.3, we'll see we're well prepared now to start dealing with the symbolic rules, equations, and inputs and outputs, and we'll start working and actually doing something that maybe feels more like math than what we've been doing so far. Okay. So any questions? Word of the day, cantaloupe. Okay. So when you finish a little bit later in my break, I'll this the nice thing is the video is actually already uploaded or it's been recording because we're live streaming. It becomes a live thing. I will put a few details in Canvas. I'll put a link to it. So if you want to see it later again, you could go into Canvas and you can fast forward and get to the spot you maybe missed or wanted to see again. There will be the quiz. So choose the word cantaloupe and you will verify your attendance. And then also there will be a link to the assignment from the first day, which is basically to share your impressions of how that first day went for you, what you feel about the class, any of those kind of things, and that'll get you the 40 plus 40 points, and we'll keep moving forward. Okay, Wednesday we'll pick up right about where we left off and just keep rolling along. Okay, and if you have questions, feel free to hang out. We'll get them done.